Hi there, I'm Heather Beadle, and today I'm going to be showing you how we've used our AASPI seismic attributes to get more insight into channel geomorphology with a particular case study using some high-resolution 3D data. This is work that was done by my master's student, Jacob Mag. We're going to be looking at a small survey, high resolution, like I mentioned, right here, kind of shown by this red, very long, thin triangle right offshore from the San Luis Pass area in kind of southwestern Texas, kind of close to Galveston and Houston, if you're familiar with that area. Some of the challenges of this data or study area were that we didn't have any well data. The area we're going to be looking at is extremely shallow, but some of the benefits are that we had high resolution 3D data, so shot at very high frequencies, and we were able to, in our area of interest, have a vertical resolution of just 2.9 meters, which is pretty amazing if you're used to working with conventional data. This is an example of what the data looks like. So kind of in the back, I'm showing our seismic data itself. We've got plotted in grayscale, some normal faults on the southwestern side, a salt diapir, some noise from a gas chimney, and then those orange unconformities, which is what I'm going to be focusing on. And if we look at what the difference is between conventional 3D and high resolution 3D from this figure from Tip Meckel at the BEG, you can see that looking at them side by side, we're missing a lot of that really shallow data in the conventional 3D. So those more recent quaternary channels are often missing in the data that we collect. So I'm going to be looking at 3 unconformities that Jake identified in the top 200 milliseconds of the 3D volume. So I'm kind of mapping them out here so you could see what he mapped over this whole volume. And we named them we identified them as unconformities because of the seismic patterns, the seismic facies. We saw some of the cross-cutting in each of these, and he spent months literally mapping these. And so these are the ones that I'll be calling the upper unconformity, the middle unconformity, and the lower unconformity. I just want to focus on the seismic attributes and just show you what they reveal to us. So first, starting with a co-rendered time structure and amplitude, we've got a map out on the horizon for the upper unconformity, the middle unconformity, and the lower unconformity. And we've highlighted some of the main features that we would see, from the main channels as blue arrows to some of the tributaries and splays. We've got some normal faults associated with that salt diapir and the salt diapir itself. If we spectrally balance the amplitude, we're able to get a little bit more information from very subtle tributaries that you can see we tried to mark out with those green arrows to larger scale amplitude anomalies, which we may be able to associate with lithological changes. Sweetness is another great attribute, very popular in the Gulf of Mexico. It is a combination of amplitude and frequency data in the seismic. And again, we could see some of those subtle tributaries and the amplitude anomalies, but we also see the striping pattern, which is the footprint of the seismic acquisition, which did cause us some trouble, but luckily in AASPI we have some footprint removal techniques that we were able to use to lessen it. So this is the lessened version. Here's our Sobel filter. So some of you may be familiar with coherence attributes. This is one type of them, and it did a great job in really enhancing what we can see with the tributary margins and enhancing where the channels are, as well as highlighting some new normal faults here in the lower unconformity that weren't quite as present and obvious to us earlier in the study. We can co-render curvature and the Sobel filter to get even more insights. So again, we see some of the acquisition footprint, but luckily as geologic interpreters, we can just look past that. And with curvature, we can now start to see some of the levees. So one good example is marked by this red arrow over here. We can see some of the channel thalwigs and more features associated with the normal faults, from the foot walls marked in yellow to the hanging walls marked in green. And then one last attribute I wanted to show today is our valley shape attribute. So in AASPI, we have attributes, geometric attributes that can show us these geometric patterns from valley shapes to ridges to bowls. And in this case, looking at valleys and channel features, we chose to use the valley shape, co-rendering it with the Sobel filter. And it did a great job of really highlighting the channels and even some of the erosive scours in this area. So that was just my quick overview. If you're interested in trying out the AASPI or learning more about our research consortium or looking more into Jacob's research, we've got his full thesis on our webpage. We have a video recording of his thesis defense pretty much on YouTube. We have a lot of sponsors, and of course, we're always thankful to like the Bureau of Economic Geology, who let us use this data and collected the data, Hampson and Russell, Petrel. And I just want to mention that this is a student research consortium that we operate at the University of Oklahoma. So we always love to get insight. We're always looking for new students who want to work with us. So thank you very, very much.